It's great to be with you. Kelly and I actually spent 3 months together in Oxford, but I guess they say if you remember the 60s, you were never really there, and I guess Kelly doesn't really remember Oxford either. In any case, it is a pleasure to be with you. In talking about these topics these days, it's really hard for me not to think of my youngest son, Gabe, because he just graduated from college, Westmont actually, and when he was a little guy, he's the one on the left, I was holding him in my arms one night as we walked out the door, and there's a glorious sunset. And I don't know, maybe because Santa Barbara is foggy a lot, or I think this may have been the first sunset he ever really noticed. And his lips quivered and his eyes got wide, and he said, "Daddy, look, God painted the sky." And I had to tell him, "Well, sorry, Gabe, God has nothing to do with it. This is just the differential refraction of light through the anthropogenically augmented particulates in the atmosphere." No, of course, I didn't say that. I entered into Gabe's moment of worship with him, and I said, "Yeah, doesn't God make beautiful things?" With confidence that when Gabe learned a bit about optics, he would understand that they were just God's brushes for fashioning his creation. And of course, one of the reasons that we're gathering this evening and in ensuing nights is to ask the question, well, could evolution be God's brushes for creating us? And I have a lot of colleagues, actually, both secular and Christians, who say, get over it, of course. Richard Dawkins says that evolution is a fact, as simply as is the fact that we get heat from the light of the sun. And actually, I want to start by recognizing that we wouldn't be here if it were that simple. First of all, if evolution is a fact, and I actually think it is, but it's not a fact like the fact that we get heat from the sun, which is knowable by immediate experience. And for evolution, there's a chain of inference, and that chain of inference, it isn't obvious like we get heat from the sun. In fact, the chain of inference causes us to question some of what does seem obvious, more like the theories that the Earth was round, or that the Earth went around the sun rather than vice versa. So first of all, it's not obvious, and if anybody's here not persuaded, I don't think you're dumb. You're not evil. You're recognizing there's a chain of inference. And second of all, unlike optics, evolution does raise some genuine questions for Christian belief. Now, it doesn't just raise the question of, could God have created by making a universe the laws of which achieve his purposes? For most Christians, and by the way, the earliest nervousness about Darwin's theories was specifically over the human issue. What implications does evolution have for understanding of who humans are? And even the creationist movement in this country, William Jennings Bryan, 3 years before the Scopes trials, wrote in a prominent article in the New York Times, the only part of evolution in which any considerable interest is felt is evolution applied to man. A hypothesis in regard to the rocks and plant life does not affect the philosophy upon which life is built. I'm actually not sure that's entirely true, but he goes on to say evolution applied to fish, birds, and beasts would not materially affect man's view of his own responsibilities. The evolution that's harmful, distinctly so, is the evolution that destroys man's family tree as taught by the Bible and makes him a descendant of the lower forms of life. Man, instead of being made in the image of God, is the development of beasts. Now, one of the things we'll want to look at is whether that dichotomy is necessary, whether that has to be an instead. But nevertheless, he's embodying the questions that many Christians have on evolution. And I take it that this month together is specifically focusing on evolution, humanity, and Christian faith. And by the way, this expression of William Jennings Bryan, one of the first American creationists, this wasn't just some paranoid fear that he was projecting upon evolutionists. So a generation later, George Gaylord Simpson, one of the maybe three most famous evolutionary biologists of the 20th century, wrote in the journal Science, which is one of the two most influential and prominent journals of science in the world. The question, what is man, is probably the most profound that can be asked by man. It's always been central to any system of philosophy or theology. The point I want to make now is that all attempts to answer that question before 1859, that's the year The Origin was published, are worthless, and that we would be better off if we could ignore them completely. The reason is that no answer had a solid, objective base until it was recognized that man is the product of evolution from primeval ages, from primeval apes. So we've got some general concerns here. I mean, can we zero in more specifically on issues in human evolution and human origins? I mean, some of them are historiographic. The identity of the first humans, where they lived, how long ago that they lived. Some of them are doctrinal. In the Christian faith, notions of imago Dei, or being created in the image of God, human innocence, and the fall. And then some of them are what you call more generally anthropological, involving theological anthropology, like the role of divine providence in the origin of humanity. Did God have some role? Did he even know that? Did he intend for us to be here? The question of human uniqueness, which is often conflated with the image of God, but they're not necessarily the same thing. Actually, there's some interesting debates about monogamy. What does an evolutionary origin of humanity have to say about whether we're built biologically to pursue and to flourish lifelong monogamy or marriage? And then most recently, the nature and reliability of moral and religious cognition. There have been, Kelly and I have both been interested in this. There have been evolutionary accounts of what are the impacts or the reliability of our capacity to discern moral truths or religious truths, if in fact they evolved. Now, there are a number of responses to this. So one response is, well, we could adjust our theology. So way back when, a famous quote from Galileo, turns out he didn't say it exactly like this, but the quote's fun. Galileo says, science tells us how the heavens go, the Bible tells us how to go to heaven. So one thing we could do is we could adjust our theology so that it didn't make any claims about the world, so that it just told us how to go to heaven. Some Christians have done this. So there's been in the science and faith community, there have been a rise of Christians arguing for religious naturalism, that God actually doesn't ever really do anything in the world that wouldn't happen if there weren't a God. And many Christians think that's going too far, that back to Galileo's quote, well, the Bible doesn't just tell us how to go to heaven. In actually all the Abrahamic faiths, the Bible also tells us how heaven came to us. It gives an account for Christianity of the incarnation, but it gives an account of things God has done in history that are theologically significant and that are important to our relationship with him. And we believe, many Christians believe, ultimately to our salvation. So wholesale theological accommodation, just you have it your way, science, will make sense of it theologically. That's not going to work for most Christians, although on some issues we may need to adjust our theology. And another response would be to do some philosophical argumentation, to say, well, yeah, the basic story of evolution is true, but these philosophical claims don't necessarily follow. I have given a version of this talk before, and I've lamented the fact that although there are maybe a dozen recent books by really prominent philosophers that do a kind of comprehensive exegesis of evolution and say that on almost every major issue, the entailments are subversive of theism in Christian belief, and there isn't a comparable volume from a Christian perspective. And recently, actually, he's here with us, but I think Al Pleniga has made a stab at that, not just on evolution, and we need more. So this is in part a recruitment talk. If there are any students in the audience, I hope we can do more of that. But yet another approach would be scientific revisionism. We can ask the question, is the science being presented to us accurate all the way down, so to speak? And there are different levels of this. You could actually reject the adequacy of evolutionary theory, and this might sound like nervous Anti-intellectual creationism doesn't have, there's a continuum even here. You could believe that evolution is just untrue. Human beings were created by a process that didn't involve it at all, directly from the dust. Or you could believe that it is true, but it doesn't tell the entire story, that there are aspects of human, you could be a dualist and think that there are aspects of human personhood that didn't evolve because they don't have to do with matter. And there are other ways that God could be involved in the process that didn't necessarily involve evolution as the story's told. And then one other way, and actually I want to emphasize this a little bit this evening for the rest of our time with you. You could reconceptualize how evolution operates. By the way, the field of evolutionary biology is often presented as monolithic in its understanding, but it really isn't. It's at an extremely interesting time right now where there are fascinating and very vigorous internal debates, and a lot of what gets served up on public representations of evolution represent extremes in those debates that not all evolutionists agree with. So we'll touch on that a little bit as well. Now, I want to add, before I jump in, I want to be honest with you about how I'm going to go about this with you. As Christians have tried to relate their faith to the natural sciences, if they didn't take the Galileo quote, that they don't overlap, there have been a couple of ways that they have done this, and these aren't mutually exclusive. I mean, one way is what's been called natural theology. You go digging at the beach, or you're at the beach with your dog, and the dog finds some buried treasure, and you say, aha, there must have been pirates on this beach. So the discoveries of science fund conclusions about the existence or the character of God. Now, there's another way to do this, and here I'll get a little personal with another sunset story. I mentioned to you Gabe, my son, saying, wow, Daddy, God painted the sky. Well, I wasn't brought up in a believing household, and as I was getting ready to go off to college, I really wrestled with the question of whether there was a God and a purpose to life, and did a lot of reading and went to the beach one day and said, I'm not coming back until I decide. And I had a sunset experience. As the sun was setting, I thought, this world is so beautiful. I actually want it to have been created by a God who's a moral being and who has a purpose for my life. But I don't have enough evidence. I can't give myself to that belief. And it was years later, and I'm not going to share the details with you, that my whole life changed by being persuaded, not so much by the kind of evidence that science discovers, but by an encounter with Christians and actually the experience of his ability to change my life at the deepest levels, that I was deeply and irrevocably persuaded of not only the existence, but the beautiful nature of the being of God. And in a sense, in contrast to natural theology that might conclude that God exists or make conclusions about what kind of God he is on the basis of scientific discoveries, for me it was more like, well, I already know that pirates exist. And in fact, this pirate has given me a map, the scriptures. And this map tells me where I might go digging for truth. In a sense, it might be one way to relate our faith to science is to say that we bring to science the entire sum of everything we already believe to be true. And then what we believe to be true fuels our estimation of the plausibility of what might or might not be true as we do our investigating. Are you with me? So the reservoir of plausible hypotheses can be influenced by the commitments that we bring to our work, theistic or atheistic. It's like we're out fishing and Jesus shows up on the beach and he says, throw your nets out on the other side of the boat. And, the disciples thought, well, we've been out here all night. They've been on this. And it might be that the Christian faith might say, throw your nets out on the side of the boat that doesn't in every way conform to the naturalistic presuppositions of the day, and who knows, we might come up with a load of fish that we didn't come up with before. And on the other hand, we have to be honest. If when we come up with no fish, we have to do our inquiry as honestly and with as much integrity as anyone else. I think, and he can tell me if I'm wrong, that I didn't have a word for this approach until I began to read some of Al's stuff. He calls it theistic science. But it's not just theists who are promoting this claim. So the Nobel laureate Francois Jacob says to produce a valuable observation, one has first to have an idea of what to observe, a preconception of what's possible, and this look is necessarily guided by a certain idea of what this so-called reality might be. It always involves a certain conception about the unknown, that is, about what lies beyond that which one has logical or experimental reasons to believe. So that operates in science, and I don't think it's bad to let these commitments come in. What's bad is not to not acknowledge them. So what I want to do with you in the time remaining is kind of look at some general evidences, specifically in the area of human evolution, that there's widespread agreement on. Doesn't make it true, but there's widespread agreement on, regardless of starting commitments. And then also look at some really fascinating controversies that are still emerging. By the way, before we jump into the data, this notion of preconceptions, I mentioned to you the quote by George Gaylord Simpson, who says we have to throw out everything before 1859. And just last week, I ran into, from archives of his personal correspondence, a letter that he wrote, in which he says the whole history of mankind testifies that acceptance on faith of supernatural or of non-natural postulates or hypotheses is stultifying at best. So this was the commitment that Simpson started with in doing his work. We'll look at some claims of evolutionary biology that might look different if we didn't start with those claims, and some that look the same, seem to look the same no matter where you start. So 2 points, just some general evidences and then emerging debates or interpretations. Now, I have to tell you, the general evidences, I mean, this could be not only a whole course, but, a whole PhD program in any one of these areas. So these are going to be snapshots. I'm not going to make an attempt to panoramically or comprehensively paint the field. In fact, again, autobiographically, I'm just going to share a couple of areas of evidence that have been influential in my own life. So when I went off to graduate school, based on my whole way of understanding the world had changed as a new Christian, and I think I kind of went off to learn enough to demonstrate that evolution was false. And it wasn't a matter of being socialized into losing my faith. Some things I found persuasive, and other things I'm still wrestling with. So here we go. First of all, fossil data. There's been an explosion just in the area of human anthropology, even over the last decade. But I want to zero in on just one area of fossil data because it's been made use of by a number of my colleagues, Christian colleagues who doubt evolution, cranial capacity, or what's sometimes called slightly different measurement called EQ, or encephalization quotient, which is a ratio of cranial capacity or cranial mass to body mass. So here's a graph from a book. I think it is the best evolution doubting book on human evolution out there by Hugh Ross and Faz Reina. And this graph is of the encephalization quotient of the four main hominin fossil finds leading to and including humans. Australopithecus, which includes the famous fossil Lucy that you may all have heard of, Homo habilis, Homo erectus, and Homo sapiens. And they point out that there's very little change early on, and then, bang, a big jump. Now, by the way, if you had a nice series of intermediates, that wouldn't prove evolution. But on the other hand, lacking intermediates is a real problem for evolution. And these are averages here. So what happens, they're averages for the entire time period. So it's one number for the entire time period. What happens if you look at the average over the time period? And it looks like this. Australopithecus and habilis didn't change much. Big change in Homo erectus. If you take the average at different times over the period that erectus existed, But this is only 4 species. What happens if you throw in a few more species? And it looks like that. But these are still only averages. What happens if you throw in the raw data? And here's what we get if we look at the raw data. And I don't know any prettier graph of the relationship between dependent and independent variable. Now, I have to say, though, so the claim, at least in this area, that there are big gaps is just not empirically accurate. But the question still remains, what does this mean? And evolutionary, there's a difference between what I would call an anatomical intermediate. That's just something that is between 2 things. So these are intermediates. They're intermediate in size and they're intermediate in value. That's just an observation. They are. But to claim that they're transitional forms, well, that's an interpretation. And it so happens that in this case, it would be an interpretation that's false, right? I mean, quarters don't turn into silver dollars or half dollars. So now back to the question of the fossil record. The observation is that we have a stunning series of anatomical intermediates. In terms of which are transitional forms, what gave rise to something else, there's actually a good deal of debate. So a very old and classic debate, these are the 4 species that we've been talking about all along, are between Don Johanson and the Leakey family. And Johanson puts Lucy, or Australopithecus, in the line that led to humanity. The Leakeys kick that out, and they put Homo habilis as the first hominid ancestor of human beings. Of course, they're the ones that discovered Homo habilis, and Johanson's the one that discovers Afarensis. And you get paid a lot of money and you get very famous for discovering the first human ancestor, less so if it led to an extinct line of great apes. But even this debate, though it's a classic one, understates the level of debate. So this is a graph from Ian Tattersall, who I think is a wonderfully fair-minded human evolutionary biologist or physical anthropologist. I was at some meetings with Tattersall just a few months ago, and he says, now this is even outdated. We have more uncertainty than we do from this particular graph. This graph draws a bunch of hominin fossils with solid lines indicating what are widely believed to be transitional forms and dotted lines indicating what nobody agrees on. And most notably is the 4 fossils that I teach every year in my intro bio class are all connected by dotted, not solid lines. So from the fossil record, again, if I were going to summarize it in one word, and this would be true, by the way, with other traits as well, we have a stunning series of anatomical intermediates. When Darwin wrote, that wasn't true, and he said if it didn't fill in, that would be a problem for his theory sufficient enough that it should be rejected. Well, it has filled in. It's filled in stunningly, but how to draw the lines is not answered altogether by fossils. So what do? Well, we can be helped in drawing the lines by genetic data. Because unlike fossils, which don't tell us what gave rise to what, genetic data can help us do that in much the way we can look at texts from ancient documents and on the basis of how many changes have occurred, make inferences about what the original text was. Now that's not error-free either, but it helps us get there. So there are a couple of ways that genetic data have informed this. First, the earliest attempts were measures of genetic similarity. And in fact, when we first began to do this work, we couldn't actually describe the exact sequence of genes or nucleotides in genes. We had to estimate them by various measures. But more recently, we've actually sequenced the human genome, and then we sequenced the chimpanzee genome, found they were 96% identical. And then after that, just a year ago, we sequenced the orang genome. And then just a few months ago, we sequenced the gorilla genome. And we've since, even in recent weeks, sequenced genomes from other primates. And It turns out that the imputed phylogeny based on anatomic data corresponds virtually precisely with the phylogenies computed by looking at genetic data. Now, the ages of divergence don't always agree. That's another question. But the relationships seem to agree. But now you might say, well, okay, but that doesn't show that one gave rise to another, because if creatures look like each other, which they obviously do, we look more like gorillas than we look like ducks, except for Kelly. Sorry, you're sitting in the front row. Well, then, of course, we'd expect their genes to be similar. So now we can ask another question. What if we look at genes that don't contribute to the structure or the function of a particular and we can look at the similarity of what's called redundant or non-functional text. So an example of redundant text is the genetic code in your body works by words called triplets or codons that have 3 letters. And the last letter in every word, in almost every word, is redundant, meaning there are different letters you can put in that word and it will specify the same thing. It'll code for the same protein. So the first 2 letters are crucial. The last letter, there's some slop. And we can ask the question, how similar are the last letters in triplets or codons between humans and chimps, humans and gorillas, humans and orangutans? And if they're very similar, that suggests common descent because it's not functional. And it turns out the exact, almost the precise percentage of similarity exists between those and the functional text. Now, one other area, and this is the area that I have found most persuasive, is the degraded text or pseudogenes. And by the way, by this, some of you may have seen recently some articles on junk DNA. And I, along with a number of biologists, never liked the phrase junk DNA. We're never persuaded that the genome of humans or any other creature carried around massive amounts of genetic material that did nothing, in part because just the costs of replicating that in each cell are enormous. But this is not junk DNA writ large. This is a very specific kind of DNA that is almost identical to genes in other organisms that have a very specific function, but they've had a mutation that debilitates them, and they don't do anything. So a graphic example of this is the pseudogene for vitamin C in humans. Turns out that to make vitamin C, it takes 3 enzymes. Humans are missing this enzyme, the GULU enzyme, as are, you'll read in text, all other primates. Actually, most other primates, very primitive group, prosimians, can do it. But higher primates and more modern primates and humans are all missing this GULU gene. If you look at a rat, that's what a portion of it looks like. And if you look at humans, chimps, orangs, and macaques, they're missing that and they have a deletion. They're identical, this portion. Now, other portions of the pseudogene vary a little bit. And if we look at how they vary, chimps and humans are very similar, orangs are farther, macaques are farther, and rats are very far away altogether. A gene that does nothing is more similar and more closely imputed DNA of organisms. Same thing with olfactory genes, by the way. Primates have a bunch of olfactory genes that they're almost identical to olfactory genes in other mammals, but not quite. They don't appear to do anything, and they're closer to the more closely related or imputedly related primate relatives. Okay, last is we can look at, in a sense, the bookshelves on which this genetic information is shelved. Now, what book shelving system you use maybe doesn't matter too much. You want in a library volumes that are very closely related to each other to be next to each other, I guess. And that's how our chromosomes work. Genes that require each other to work are often found very close to each other on the same chromosome, but wildly disparate subjects, they could be on any chromosome. And furthermore, the number of chromosomes you have doesn't, or the shape that they take, doesn't appear to have functional significance. But we might ask, well, how similar are where the genes are, the shape, the number of chromosomes? Biologists call this a karyotype, the chromosome number and shapes. And if we look at the karyotype of humans, chimps, gorillas, and orangs, they're almost indistinguishable. The number, the size, the shape. In fact, back to the Who Was Adam book, Hugh Ross and Foz Reyna acknowledge this. They say, when aligned, human and corresponding chimp chromosomes appear to be virtually identical. Actually, it's not just chimp, it's the other great apes as well. And this is a schematic representation of the identicalness. If you look at the actual article in which these data were first published, though, there's the actual article. I mean, now there's not a probabilistic argument here. It's just a question. I have to say that when I first saw this took my breath away. The degree, the conformity, the banding patterns, and the shapes and the number of chromosomes is stunning and suggests common descent here. But there's one interesting difference. Chromosome number 2 is from great apes is not a single chromosome for human beings. Or, excuse me, chromosome number 2 for human beings is not a single chromosome in the great apes. So that's a difference in karyotype, and it suggests a question. If there was common descent, then it suggests that the human chromosome number 2 is a result of a fusion. Now, is there any way we could test that? And by the way, if there were, and if we could test it, and we can, and I'll say, and it wasn't that many years ago, but this, perhaps for me, more than any other finding in the recent biosciences, has been the most persuasive. And here's how a fusion would work. If you take 2 chromosomes, and every chromosome at the ends has a region called a telomere. It's kind of a bumper. And in the centers has a region called a centromere that helps the chromosomes line up during cell division. And if you fuse 2 chromosomes, well, then you ought to have a chromosome with 2 telomeres in the middle, which they don't usually have, and 2 centromeres rather than 1. And the question is there any evidence of that? And in 2005, we actually found that. We found a defunct region in human chromosome number 2 of a centromeric sequence and telomeric sequences as well. Now, one last question. You could say, and by the way, this conversation between Christians, at least the number of the Christians that I'm hanging out with these days, has been extremely cordial. So I get together frequently with Hugh Ross and Foz. We share the podium together, but we also get together privately. My dad died a couple of months ago, and the whole Reasons to Believe staff sent me a condolences card where they signed it individually, told me, and I know they told me that they were praying for me. This isn't a schmaltzy indulgence, I hope. It's a confession of the fact that in the body of Christ we can have unity between those who differ on these issues. And I have immense respect for how they conduct their science. So in their book, they argued that there wasn't good evidence for chromosomal fusion. And now Foz is acknowledging there is good evidence for chromosomal fusion, but he has an alternative hypothesis, and that is that human beings were created directly by God with one more set of chromosomes that fused. And that's actually a perfectly plausible hypothesis. And it's only within the last few weeks, actually, that we have provisional data to suggest that that's not true. We've actually gotten DNA from a non-human Neanderthal-like fossil find, the Denisovan fossil, and we've been able to locate sequences of degraded centromeres in those fossils that suggest a chromosomal fusion in these organisms. So now there are 2 hominin fossils a human and a not human fossil with a chromosome fusion that suggests this fusion happened before either the rise or at least the ascendancy of human beings. This is one paper. We'll have to see how other studies check out. We don't have enough quality DNA of Neanderthals to do this, but that will be really important if and when we get those data. So what inferences can we make from this information? Well, first of all, and I say this tentatively as any scientist would and as I think any Christian would, but the data really look like humans share ancestry with other creatures. Does that mean that we're only animals? Well, no, it doesn't mean that in any way, nor, by the way, would it mean that that all living systems were only matter. There could be qualitative differences, even if discontinuities, even if there's material or phylogenetic continuity. But it looks like common descent is the case. It also looks like the most prevailing interpretations of the data these days suggest affirm what's been called the recent shared origin, or that should be an O, RSO, or out of Africa hypothesis. There's been a debate in evolutionary theory. It's been waging for the last generation, but actually it goes back all the way to Darwin. They use different terms, monophyletic versus polyphyletic. Did we all share one family tree, or did we emerge into humanness at different times over in different periods of history in different places? By the way, the latter theory has been used at many different times in history to justify racist programs. Now, that doesn't make it untrue, but it's easier to say the races are qualitatively different if they had different points and times of origins. And it looks on the basis of genetic data that the out of Africa or recent shared origin hypothesis looks to be the case. I'm oversimplifying that a little bit, but for purposes of time. But humanity appears to be all the same family with an origin in a shared population at a same shared point of time in the relatively recent past. And in fact, if you look at genetic diversity of human beings, the farther away you get from Africa, the higher the diversity. How about Adam and Eve? Now, that's a hot topic. You're going to have a whole session on this, I know, later, so I'm not going to concentrate on this, but I want to make a couple of comments. And the first comment might sound like I'm fudging here, but it depends how you construe Adam and Eve. Now, I know there are many, many different ways of reading the Genesis text. Some people, and some people who know a lot more about the text and the language and the prevailing culture than I do, argue that it shouldn't be read historically. If you did read it historically, well, some people think it refers to real individuals, but there were other individuals at the same time. I mean, who did Adam's sons marry, and who was Cain worried was going to kill him, that kind of thing. And that they take Paul's view in Romans very literally, that maybe there are historic individuals who infected humankind with sin. So there's a historical individual who infected, but they're not the progenitors of all humankind. Now, I'm not advocating any reading of Genesis. That's way outside my grasp. But if you look at the science, if just the genetic diversity of human beings, if we look at the genes in your nuclei, nuclear DNA, and of course you know that you got them from your mom and your dad, and they got theirs from their mom and dad, and they got theirs from theirs. Your number of relatives actually increases as you go back in time. And based on the current heterozygosity or diversity of the human gene pool, we can make estimates about the founding population size of humanity. And on the one hand, it's much smaller than we would have guessed at one time earlier. And again, these are just estimates, but it's not 2. It's from 2,000 to 10,000 members of the founding population. But let's look at another kind of DNA. And that's the DNA that is not in your nucleus. It's not on your chromosomes. It's some little organelles in your cells called mitochondria, mitochondrial DNA, which you get in the egg that was fertilized, meaning all of your mitochondrial DNA you got from your mom. And she got it from her mom. and her mom got it from her mom. So although the number of relatives increases as you go back, every one of you has one and one and one and only one female relative, all the way back to whoever the first person was that you're descended from. And now we can ask this question. Let's look at Al Plantinga's maternal DNA and Kai Hammond's maternal DNA and ask, what's the likelihood, or is there any evidence that they shared the same maternal relative? And you may know this story, but the answer to that is yes. The individuals called mitochondrial Eve, dubbed generically the most recent shared ancestor. Again, we would have never guessed this, but studies of mitochondrial DNA suggest that human beings do have in their ancestry a shared ancestor, a shared single ancestor. That's not the same as saying we all came from that woman and only that woman. There are other contemporary women who contributed to the gene pool, but you may not be related to her, and you may be related to her, but there's at least one person to whom we're all related. And we can do the same thing with Y chromosomes, which you only get from your father. And that's called the Y chromosome Adam. So actually it does look like there was an Adam and an Eve. Now, estimates of when they lived, they weren't living at the same time. That makes it a little hard, except remember, this is the most recent shared ancestor. So the most recent shared Adam is younger than the most recent shared Eve, but that doesn't mean that there was an older shared Adam. So I'm just giving you places to stand and not suggest where you should stand on this, but the claims that the science is absolutely antithetical to any historical reading of Genesis, I think are way overstated. Although there's big tensions between the current science and believing in a single Adam and Eve as sole progenitors of humanity. Okay, now let's roll up our sleeves in the time remaining. I mentioned a range of issues like monogamy. That's a fun one, and we're not going to treat it here, but I will just say one sentence about this because it's so encouraging that one of the co-discoverers of Lucy, bioanatomist named C. Owen Lovejoy, has been arguing for 30 years and then arguing more vigorously now in light of the discovery we've made, Artie or Ardipithecus, that humans are biologically, and he has no theological agenda here, it's just based on anatomical evidence, are fundamentally monogamous, and it's not only a primordial trait, but it's a trait that drove the rest of human evolution. And that's a view that a generation ago would have been laughed out of town. But I want to look at two issues that I mentioned at the very beginning. Providence and human origins is one of them. So again, these aren't paranoid Christian fears about what might be the consequences of evolution. Many leading evolutionary biologists are suggesting if you buy evolution, you got to reject providence. So George Gaylord Simpson again, sounds like I'm picking on George. Man is the result of a purposeless and natural process that did not have him in mind. He was not planned. There's a philosophical comment that we could make here. I mean, Al and many others have made this case. I mean, how could science make this judgment? And what does it mean for a process to be purposeless? There could be a purposeful agent behind a mechanistic process. But Simpson meant more than this. He means if you look at the process itself, it's irreconcilable with the idea that there could be an intelligence or agent behind it. Stephen Jay Gould, who's famous for saying there's no conflict between science and religion because Galileo was right. They don't overlap. And he made that emphatically and passionately and often. Nevertheless ended up saying, we are a momentary cosmic accident that would never arise again if the tree of life could be replanted. And he goes on to say, after having tried to assure theists that there's no conflict between science and religion, that acceptance of evolution is incompatible with the notion that there is some providence guiding evolution or who intended humanity. So those are big claims. And why would people make these claims? Well, two reasons. One is the claim that it's ultimately contingency that drives evolutionary change. And I know we've got a mixed, wide-ranging audience here. There's another claim that I'm not going to look at, which has to do with randomness of genetic mutations. That's easy to set aside for a number of reasons, one of which is that even if mutations were random, the theory of natural selection culls or parses or chooses which random mutations. But this seems, at face value, more worthy of consideration. That is to say that there are so many, at the macroscopic level, contingent events that if you replayed evolution again, you'd never get anything even close to what we have now. And then the other reason is, as we look at, and this might seem to follow from the contingency thesis, that as we look at the history of evolutionary change, there's no directionality. There's no thematic continuity. It's not going anywhere. It doesn't look like any intelligent agent designed it or used it or employed it in any way to get some specific result. In fact, Gould's image is that evolution is a drunk stumbling down the street, falling into the gutter in a stupor. So I want to look quickly at both those things. The contingency, Gould's favorite example of the contingency is, we had the rise of mammals with this dramatic extinction about 65 million years ago, the boundary between the Cretaceous and the Tertiary period. And we have thought that extinction happened because of a massive impact on the Earth. And actually, we've recently found, first of all, a clay layer right in the boundary between the Cretaceous and the Tertiary layer that suggests all these suspended particulates from impact settled. We found a spike in iridium at exactly 65 million years. Iridium is an element that's very rare on Earth, very common in meteors. And then most recently, we've actually found an impact crater dated at 65 million years off the Yucatan Peninsula. So the evidence looks good that there was a massive extinction, and it was fueled by, in one sense, this wildly contingent event. Although, parenthetically, I'd say, well, the fact that an event looks contingent, is Gould saying that God didn't know that an asteroid would strike Earth? That would seem to be a claim that science couldn't make, and I actually wouldn't think it surprised God altogether that something happened in his universe. But the interesting empirical findings, and I regret that Gould wasn't around to weigh in on these, is that when we zero in on the rise of mammals, a few years ago we found that the rise of mammals actually happened about 35 million years before the massive extinction event. So maybe it wasn't so contingent after all. Maybe there's a certain dynamic to natural selection, and we're going to get to that in a minute, that it would have happened anyways. And in fact, if we take this article is just a year old, if we take a more fine-grained look, it so happens that this extinction event, if you look at the diversification of primates, that was well before. Now, there's still a tremendous proliferation of other mammalian lines after the extinction. But primates had a lot of work done before. So just empirically, the massive contingency hypothesis doesn't seem to hold water. And then a paleontologist named Simon Conway Morris, who's a Christian, by the way, has argued on the basis of much more wide-ranging studies that if you look at the fossil history and if you look at existing organisms, you have evolutionary convergence over and over and over again. Evolution seems to come up with similar structures and comparable solutions, anatomical and morphological. So Simon wants to argue that the exact opposite is the case. If you ran the tapes of evolution over and over, you'd always get something close to what we have. The reason this is especially interesting is before Simon made this case, he was the leading expert on a group of fossils called the Burgess Shale, which Gould drew on very heavily for his work, and he called Morris the most brilliant paleontologist of the last 100 years. And then they had actually a regrettable falling out. But nevertheless, so you have these two iconic figures battling it out. Just empirically, it looks like Morris was right on this. But there's another question we we want to address quickly, and that's this issue of directionality. Now, convergence is not the same as directionality. So that's what Simon's been working on, and you can think of it in this way. You're at a bingo game, and the same numbers keep popping up. That's convergence. Directionality would be if there's an ascending series of numbers. And this has been an extremely unpopular position in evolutionary theory. And if you're going to ask me, I would say I find the single most scientifically exciting and theologically provocative recent idea emerging in evolutionary theory is the idea of deep directionality. Now, there's some directional trends which many people agree on, an increase in body size called Cope's rule, and an increase in sensory acuity, and lots of other trends. But this deep directionality concerns a series of what are now called major evolutionary transitions. And transition theory says that there are a series of major breakthroughs that have a shared thematic trend to prokaryotic to eukaryotic cells, cells without any organelles to cells with organelles living inside of them that are thought to have previously been free-living cells themselves, unicellular to multicellular organisms, asexual to sexual reproducers, solitary to eusocial organisms. You see the theme here? The theme is actually interdependent cooperation, that previously autonomous living organisms come to not only cooperate with each other, but to be requisite cooperators. If you're an obligate sexual reproducer, you need a partner. If you're a multicellular cell, you need your other cells. Paul uses this in his reference to our life in the body of Christ, too. And so what you have over evolutionary time is an increase, a progressive increase in synergistic, interdependent cooperativity. By the way, the last transition suggested is the transition from primate to human sociality. I mean, here, I love these pictures because they look very similar in terms of the group caring for the offspring. But the difference is this. The difference is that in human groups, this caring is mediated by information which is not genetic and which is transmissible far beyond the immediate social group. So you have these trends in major evolutionary transitions, and it may in fact just be the case that if you ran the tapes, there's a logic to evolutionary theory that would get us what we have now. A generation ago, Michael Polanyi wrote in Science, we can recognize in a strictly defined progression, rising from the inanimate level to ever higher additional principles of life. And this has been, well, if not mocked, at least severely dismissed for the last generation. But in light of this evolutionary transition theories, biologists have returned to this idea of an innate progressiveness to biological history. And in Nature, Carl Sagan wrote, this progress, he's quoting Polanyi here, nowadays described as a series of major transitions in evolution, is often due to the emergence of new cooperative units. So I hope I'm conveying some of the ferment and changed opinions in evolutionary theory and some of the excitement that, theist or not theist, there is a thematic trend to the history of life which suggests actually that it is going somewhere. Now, by the way, that doesn't mean that it needed supernatural guidance. Now, it doesn't mean that it didn't get it either. Science can't rule that out. But it does mean that the actual path of evolution is concordant with the notion that a God might employ it to attain the purposes of beings who are not only capable of reason and symbolic communication, but perhaps most importantly, a level of interdependent cooperativity, of love, that is rightly considered the culmination of the created world. And with that, we're approaching 7 o'clock, so I want to say just a couple of words quickly on this notion of culmination, the question of human uniqueness. So from Darwin on, I do have to say that most biologists thought that a necessary entailment of evolution was the degradation of human uniqueness, that if we had phylogenetic continuity, we had to have phenotypic continuity. The traits had to be comparable. And so Carl Vogt, one of Darwin's contemporaries, in Germany said, Darwin's theory turns the creator without any hesitation out of doors. Man is not a special creation produced in a different way and distinct from other animals, endowed with an individual soul and animated by the breath of God. My colleague, Franz de Waal, and he's a wonderful, gracious person with whom I've had the privilege of private and public conversation, but Franz is very convinced it's the rare claim of human uniqueness that holds up for more than a decade. We have no basic wants or needs that cannot also be observed in our close relatives. And then he goes on to say, they, like us, strive for power, enjoy sex, want security and protection, kill over territory, value trust and cooperation. So there's an assumption there on Franz's part, actually, about what it is that we all want. And then most recently, I was just surprised to see this in Nature, lead article, lead editorial, with all deference to the sensibilities of religious people. The idea that man was created in the image of God can surely be put aside. So I want to acknowledge I have some, again, Christian colleagues who say, kind of like in Macbeth, where he's exhorted by his friend after knowing that his whole family has been killed, where he's exhorted, bear it like a man. And he comes back and he says, I must first feel it as a man. And I actually think there's a weight of dissonance in the atmosphere right now that it would be irresponsible not to acknowledge. But the question is the weight appropriately ascribed? Do these ideas, in fact, ensue from evolution? In order to respect our time, I will say that we can discuss these more during the discussion period, but I'll close with two quotes. This is good stuff. First of all, there's one group of biologists who are saying, hang on, there's nothing biologically transcendent about human beings, but there is something unique about them, and it's the scale of cooperation. There's an explosion of literature on this topic recently. I actually don't know of an evolutionary ethologist who would disagree with this, that the human cooperation exceeds that of all other species. And in fact, E.O. Wilson, who wants evolution to become the dominant religion of the day, who's an atheist himself, nevertheless, in his book, both the original and the edited reissue recently, Sociobiology, says, man has achieved an extraordinary degree of cooperation. Exactly how he alone has been able to cross to this pinnacle is the culminating mystery of all biology. And he wasn't being hyperbolic here. There is something unique. It doesn't in and of itself suggest a miracle, but we actually haven't solved it biologically. And then lastly, there are some intimations not just of biological uniqueness, but biological transcendence. And one of those things, one of those intimations is the notion that humans, and it appears that only humans, have developed a separate system of information, extrasomatic information. That is to say, information that is symbolic and that can be stored outside human cells. Now, writing would be an example of that, but art and carvings would be another example of that. So human beings have developed extrasomatic information storage, and that suggests the fact that to the extent that information informs our phenotypes, informs human traits, that natural selection operating on genes doesn't get the entire job done. And again, this is, now, how to make sense of this is broadly disputed amongst biologists, but that it is the case is not disputed at all. In fact, Dan Dennett, a really aggressive atheist, says we have built-in desires to reproduce and do pretty much whatever it takes to achieve this goal, but we also have creeds. We said one in church this morning. And the ability to transcend our genetic imperatives. I almost can't believe that Dennett is saying this. This fact does make us different. And none other than Richard Dawkins, in commenting on altruistic behavior that humans exhibit that might increase somebody else's fitness at cost to their own. I think this is the strongest affirmation, not only of biological uniqueness, but biological transcendence that I've encountered in 20th century literature. And it comes from Dennett. In fact, in my reading, it might be too strong because he takes altruism out of nature. But Dennett says, we have the power to defy the selfish genes of our birth, cultivating and nurturing a pure, disinterested altruism, something that has no place in nature and that has never existed before in the whole history of the world. We alone on earth can rebel against the tyranny of the selfish replicators. Now, he actually doesn't propose a theory that anybody has deeply accepted on how this is the case. So there's lots of room for scientific and philosophical and theological discussion how it's the case. But if you were to ask, does evolution subvert the idea of human transcendence? I would actually say the opposite's the case. That through the lens of natural selection and the paradigm of common descent, it becomes strikingly evident how human beings are transcendent. And there's, we may want to discuss how that's the case, but that is the case is not subverted, but illuminated and affirmed by evolutionary theory. And I'll close with a quote by Pascal, setting it up with Paul's affirmation that we have this treasure in human vessels, that there is something transcendent about us. We probably shouldn't be threatened by the fact that the treasure is instantiated in material beings. And Pascal says, man is neither angel nor brute. And the unfortunate thing is, he who would act the angel acts the brute. Meaning, we're not brutes, but if we think we're only angels, the very love which commends the reliability of our faith is jeopardized. And knowledge of our brutishness forces us to a Savior in need of redemption. And I'm glad that we're here together this evening celebrating that. Love to have some conversation.
What we're going to do now is it's a chance for people to ask questions. You can ask them out loud if you like. If you don't, Jack is going to get some paper or somebody and pass it around, paper and pencils or pens, and you can put your question down, and he'll hand them to me, and I'll read them for you. The first thing is, I wonder if you were taking back the Out of Africa thesis. If Alvin Plantinga and Kylan Van Hamen share a mitochondrial Eve, might the first ancestors come out of the Nederlands? That's just no. One question I have for you, and it's an issue that's probably on lots of people's minds. How did evolution come easy to you? Is this something that you had to? One thing you didn't put up there exactly is how you might square your belief in evolution with what the Bible says in the first 3 chapters. And is there some way that you came to understand God created the world in 7 days and evolution?
Well, having been grafted into the evangelical community, I know many, many people who wrestled with this, trying to make sense of evolution and science more generally in light of their background. That just wasn't my own story. I grew up in a family of German Jewish Holocaust refugees who some of them didn't believe in God at all, and those who did weren't troubled by the sciences. But when I became a Christian, I didn't even know this word then, but I would say now, my whole epistemology changed. I didn't understand everything that the Bible taught. I hadn't even read the whole Bible yet, but I believed if the Bible taught it, it was true. Now, so I did have some struggles, but I entered into my reading of scriptures without having had previous instruction. And I was nurtured by a number of different Christian groups. My home church as a new Christian was an Assemblies of God, a very fundamentalist organization. I just went to the funeral of my pastor, my first pastor, who I love to this day. And they would have had a young Earth, no evolution perspective. But the interesting thing is, in the assemblies, they didn't talk much about that. They were interested in getting out in the streets and saving souls, and I really mean that. And they were more experiential than doctrinal, and so although they believed it, it wasn't a big deal. And then I went to Wheaton and got a number of different perspectives there as well. So I have to confess, in my own walk with Christ, it hasn't been a huge deal. Although I think there was a reservoir of skepticism as I looked at the picture of humanity that came through the scriptures and the picture of humanity that was given by the prevailing evolutionary accounts when I was a young Christian. But I think that picture has changed in evolutionary theory these days. And although you have strident atheists like Dawkins and Dennett, there are a number of evolutionary biologists, some of whom are professing Christians, but some of whom aren't theists at all, who just think they're completely wrong, not only in their assertion of the entailments of evolution, but they're even wrong in their portrayal of how evolution itself works. And I gave you a couple of examples of that.
All right, the floor is open for questions. By the way, put your hand up if you'd like Jack to give you a card you'd like to write something on, and you can put your hand up. I'm kind of looking around to see who might like to ask a question.
Jeff, I've read some folks lately who seem to feel that the concept of the mitochondrial Eve, as you articulated it, has been debunked. Now, I don't understand their arguments well enough to be able to tell you why they think it's been debunked, but I wonder if you're familiar with the debate enough that you could comment on that.
Well, there are a number of debunkings. So the first debunking is a debunking of the misuses to which mitochondrial Eve was put by a number of theologians, but also by some scientists that didn't understand that concept. And that's been, Francisco Ayala has been doing this for a decade or so. And what Ayala wants us to understand is mitochondrial Eve does not mean that humanity all emerged from a single female. And that's not what the guy named Wilson, the original developer of the idea, meant either. He regrets using that term now. So that's a major debunking, but that's not what it meant to begin with. It doesn't mean that all humanity emerged from a single female. It means that all humanity, while sharing genetic legacy from many females, all of whom share at least one. And some people argue that, majority doesn't rule in matters of truth. There have been some proposals that we can develop mitochondrial matrilineal lineages, and there might be as many as 12 of those. And that's not the majority opinion. The majority opinion is that the genetic data do point to a single, most recent shared ancestor, but we'll have to see where that ends up. Same debates exist with Y chromosome Adam.
Jeff, thanks very much. That was extremely informative. And I'd like a little more information about transcendence. You said even Dawkins and Dennett recognized transcendence. I wasn't sure what the transcendence is transcendence of, You transcend something or other, I guess. And I'm not sure what examples of it would be. Would say people being able to do physics or evolutionary biology like you do, or do great music or poetry or whatever. Would those be examples of the transcendence, say, and you have in mind? Or would it just have to do with altruism? I was a little puzzled by that.
Yeah. And that depends who you talk to. And I actually, here I need help from philosophers, but I don't think the meaning of transcendence is very rigorously thought through here. But so as I read the literature, there are two different meanings. One meaning is that the activities and the information that the activities that human beings exhibit and the information that human minds generate is not reducible to the information that we is materially instantiated in us. And the reason people argue for this is that there is a certain adaptive value in being able to respond to changes in the environment. And the genome is very slow in responding. So this actually constitutes something of a criticism against evolutionary psychology, which argues the major dispositions and cognitive structures of the human mind are structured by the genome as a result of the effects of selection. And critics of that will say one guy is a guy named Henry Plotkin at Cambridge, and Plotkin says, well, that doesn't make so much sense. If culture and symbolic information is an adaptation that's supposed to increase the fitness of human beings, why should our cognitive dispositions, out of which these concepts emerge, be reducible to genetic information? So Plotkin and others want to argue that it has to be, he uses the word uncoupled, that the human mind and the concepts that the human mind generates have been uncoupled from the action of natural selection on our genes. So I think by uncoupled he means transcends. And it doesn't mean, well, we don't need genes to do thought. It just means if you know our genes, you don't know our thought. And if there are convergent or cross-cultural patterns in human concepts, it doesn't necessarily mean that our genes are urging us there. It just means that people may figure out the same kinds of things. So that's one thing that transcendence means. Another thing, a stronger thing it means is, no, it's not only uncoupled, it actually opposes. That there's something that human beings can do with their minds that motivates behaviors that are contrary to what our, if we have such things, our genetic default dispositions might be. There's a big debate in biology, so the geneticist at UCSB, Gunther Stent, has said that's an absurdity, that biology could give rise to something that resists biology. And I think I quoted Franz de Waal, who's really passionate about saying there's nothing different about fundamentally different about humans and other organisms. So he calls this the Gnostic view of goodness, that when we do something really altruistic, it's because it's an invention of culture, it's not our genes. And Dawkins wants to say, well, it is an invention of our culture, and in fact, it can oppose our genes. Now, he doesn't have any account for how it is our genes could create minds that are receptive to these ideas and that cherish these ideas. So I actually don't think the Dawkinsian account is an explanatory account that gets us any traction, but it is an acknowledgement. It's an acknowledgement that humans seem capable of things that aren't explainable on the basis of natural selection operating on our genes.
Thank you so much for coming out. Great presentation. I'm interested in the idea of cooperation as a positive value or not. In particular, I'm thinking about the evolutionary value of cooperation. If, let's say, we look just at the 20th century and what human beings did was very evil and destructive of other human beings in just that century. And part of that cooperation being driven by certain creeds. I'm not thinking just of religious creeds here. So why would you think that we should put a positive connotation on the development of human cooperation?
Great question. Wonderful question. I'm so glad you asked it because I didn't have time in the presentation to talk about this. Here I need help from my philosopher friends as well, but I think there are a number of different ways that we can ascribe a value to something. I mean, we can ascribe aesthetic value, we can ascribe utilitarian value or moral value to something. C.S. Lewis, at the beginning of the Four Loves, talks about what it means to be like God. And he says there's two different ways that we can think of this. He talks about being like God by qualities, so that God is mighty or powerful. And for all we know, the devil might be mighty or powerful. Or we can be like God by being near to him in virtues or approach. And he gives the example, and he says, for us humans, in some sense, we're nearest to him by approach when we're least like him in qualities. I mean, when we're most dependent on him, when we're weakest. And so I want to employ that in responding to your question. I think if we look at the history of evolutionary theory, what we have is an escalation of what the philosopher of biology, Hans Jonas, called biotic potency. We have organisms becoming progressively more, there's no other way to say this, progressively more alive. Sensory acuity goes up, behavioral flexibility expands, ability to sense and respond to the interior life of others responds. We have the increase in maternal care, cooperativity goes up, and most importantly, perhaps, homeostatic capacity goes up. We can control our internal environment more precisely. It brings to mind these words of Paul, where he says, "Be not conformed to the surrounding world, but be transformed from within." But that's what homeostasis is. And over evolutionary history, we do that better and better. But that's morally neutral, as you say. And look, we couldn't have the atrocities of the Third Reich, from which my family fled, with organisms that weren't endothermic. I mean, I don't mean to be trivial here, but you need a certain degree of thermal stability in order to have the brains that are capable of that kind of massive organization. So endothermy and cooperation in one sense are wonderful, but they're morally neutral, and they can be used for great evils as well as great good. And the way I view it is that over the course of evolution, and this is why I reject evolutionary eschatologies, that if we just run the tape of evolution forward, we're going to reach perfection. I don't think that's true at all as a Christian, and I don't think it's true on the basis of the evolution record. But if we did evolve, what God has achieved over the process of evolution is a creature who is in need of and capable of receiving salvation. So it's morally underdetermined, but God can use it for his good purposes.
Thanks very much for your encouraging comment about the cordial and generous relationships that you have with Hugh Ross and others. I think I find that particularly encouraging because many of us, as we watch this discussion, find instead of this generosity, we often find antagonism, fear, violence, dismissiveness, even within the Christian community. And as one who's involved with this in the public and in all sorts of ways, I was wondering if you might make some comments about your experience amongst the Christian community talking about these issues, the degree of positive and negative interactions that you find and how you respond to them.
I don't remember if I actually shared these scriptures or not, but this notion, Dawkins' acknowledgement, that's what's truly outrageously different about human beings is altruism. And I think of these words from John, by this will the world know that you're my disciples, that you have love for one another. I mean, it's not that you have compelling arguments for the fine-tuning of the universe to 10 to the minus 79th. And then the assurance of Christian assurance in 1 John, by this we know that we have passed from death into life, that we love the brethren. So I actually, for me, there's nothing more important than that. I think it's crucial to our Christian witness, and I think it's crucial to our own assurance that that love for others in the body of Christ and outside constitute the essence of who we are and what we're about. And in terms of commenting on how this does or doesn't typify the landscape, my own experience is that it has been highly varied. And I'm not sure why, but certain organizations seem to have succeeded in cultivating an ethos of not just graciousness, but genuine care. I think Hugh's organization is an example of that. And others haven't. And it doesn't go by point of view, by the way. So some young Earth creationists I have found who probably have more differences with them than I do you, but I found to be tremendously accepting and affirming and celebrating of our shared commitment to Christ. And others are more brittle. I'm not sure if this is the case, but I have noticed some correspondence between the commitment of an organization to evangelism and an expression of love. I mean, for Hugh and the people in his organization, Reasons to Believe, their ultimate commitment is bringing people to Christ and actually not winning a culture war. So those are rambling thoughts. I'm confused, but I've seen both. And even within movements, I have a history of friendships with people in the intelligent design movement. And my own views have evolved over the last decade, and some of those folks I continue to have not just respectful, but deeply affectionate friendships with, and I think I'm on the blacklist of some of the people as a... So.
I'll move over that way. Let me just read this question. You can answer, then I'll get yours. Is it possible for another branch of the tree to achieve higher cognition or consciousness eventually, or to become sentient in the way we are?
Well, depending on some Christians believe that there are already maybe other creatures who are beyond us in capacities, although they may not be on the same tree, depending on your view of angels, for example. So as a Christian, I don't feel threatened that that God may have created some beings who are farther along in intelligence or spiritual capacity, or the scriptures do seem to suggest that there's one unique thing about us. He allowed all to fall into disobedience that he might show mercy to all. So we have the privilege of knowing God's mercy in a way that might not be true of other creatures. But with this evolutionary tree, is it possible that some creature could develop more advanced capacities? Well, that's a complicated and a highly speculative one. I would say in principle, it's not impossible. But I want to remind you that evolution actually hasn't fully explained all of our capacities. So imagine for a moment that some of our capacities aren't due to evolution. I'm not suggesting that there's an argument for this, but what if you were a dualist? What if you are a dualist and you believe some of our capacities were breathed into us by God? As for example, Ken Miller is, who's one of the leading defenders of evolution and critics of intelligent design theory. Ken, in his book, Darwin's God, talks about the moment that creatures that evolved to a capacity being suitable to have a spirit breathed into them. But now, if that were the case, if you believe that, then you would say, well, that evolution probably couldn't come up with another creature unless God wanted to do something special again. But lastly, just speaking in ecological terms, it seems unlikely. And the reason it seems unlikely is akin to the reasons that, if you buy the fossil record, that humans seem to have displaced other proto-human hominins. And that's because we developed a level of cognitive sophistication and cultural advancement that caused us to dominate the planet. So it's difficult to imagine how an ape or some other organism is going to evolve up through the sophistication of human culture. Now, what some people do suggest, based on this major transitions in evolution, is that there may be yet another major transition that's taking place. These transitions are all characterized, I said, by synergistic cooperation, but the other thing is the way information is packaged and transmitted. So genes became chromosomes, free-living organisms became mitochondria, single cells became multicells. Each of those cases, information was packaged and transmitted in a different way, and maybe with the rise of the global internet, there are a number of people who are taking this seriously, that extrasomatic information, which I've already mentioned before, is going to take on organismal status. And we're going to have a human-machine interface that will usher us into the next stage of evolution. That's pretty scary every time I fly an airline and they can't even find my ticket on the computer. But
We need to stop here. Before we thank Jeff, he's going to come over and have a seat at a table. If you have any questions that you weren't able to ask, please come over. And there's coffee and snacks. Grab some coffee and come over and sit down. Jeff will stay around as long as you have questions. Join me in thanking Jeff for his great talk.